Hey everybody, back with another video. I was sitting here in my basement doing some work on some ARs. Obviously, I'm working on some pole positions. They didn't actually have ARs when I got them. They were just empty cabinets. I purchased these ARs off of somebody on Clove. Which kind of interesting is they both came from the same machine, Upright 17285. They have identical serial numbers. This one here has experienced some bad heat damage right here where I think the sense line is. So I have to fix that. You can see look how bad it is on this side. I mean, literally that caught on fire. The LM305 voltage regulator has got some burned pads and stuff. It looks like it was replaced, but I'm gonna, go over that as well. So really, I was just doing some research and I figured I would share some in this video. In general, you don't need to replace these capacitors. I typically measure them to verify that's the case. But this is the first time I actually looked a little bit closer to see what these capacitors were actually doing. And you have, just at a high level, you have these two main capacitors. All of these four capacitors are in the audio amplifier section. These two are in series with the speaker, and so or speakers, and so they're actually, acting as high pass passive filters. So they're basically allowing filtering out some of the lower frequency range. They're allowing the higher frequencies to pass to the speaker, and they are in series with the speaker. Which is kind of interesting, right? And this audio, I won't get into the push-pull kind of thing, but basically it's acting in a push-pull configuration, but there's two amplifiers, so it could be stereo, but typically that's not how Atari used them. They're using them both together, probably inverted of each other. These two capacitors have to do with the inversion input into the audio amplifier. So, if these are off somewhat, it's probably going to impact your audio, but it's not likely to impact it that much where you're actually going to be able to hear the difference. Now, these two could impact the gain, because that's what I think the inversion part of the audio input is to impact and regulate the gain of the amplifier. But obviously you could adjust that too. So it's like if these are drifting, that's not that big a deal. This 1000 microfarad cap is more of a decoupling capacitor, like charging capacitor. It is on the 10 volt unregulated line. So it's, basically keeping a consistent voltage going to the voltage input of the audio amplifiers, mostly, but also I guess to anything that's powering the 5 volt regulation circuit, if something is it? Yeah, the LM305 comes off of that line as well. So it's keeping a good stable voltage and cleaning it up a little bit for the LM305 as well as the two audio amplifiers. Is it doing anything more than that? Yeah, probably the input of the Q2 as well. So this is probably, I would almost say, almost more important than these other ones. And then this capacitor here is on the 5 volt line, and I can't really figure it out like exactly what it's doing, if it's just smoothing, keeping the 5 volt line charged a little bit. That's the best I could kind of think of, I guess. But anyway, so I will test these capacitors, but usually they're not a problem. They're usually, have good ESR, and they read within range of the microfarads and stuff. And even if they're not, you're probably not going to tell. So, what I'm going to do in this video is first clean these boards and replace this, test this 2N3055, because if I see something burnt like that, I'm just going to test this and test the tip 32. I think it's a tip 32, right? Yeah. I'm going to test those before even powering it up, and then we'll test them. I've done that before, but I'm not going to spend a lot of time testing them. But what I'm more interested in is actually putting the audio signal on here and measuring the frequency on an oscilloscope. I just was, wanting to experiment, so I figured I'd share. And one of the reasons why is like on the older Atari AR boards, AR1s, like in Asteroids, this is 1,000 microfarad. So they went from 1,000 to 3,300 for a reason. On AR2s, it's always 3,300. I think on AR1s, the original Asteroids, it's like 1,000, and it might be like 2,200 on Asteroids Deluxe. I can't remember. But it definitely impacts the bass or frequency response, and I just wanted to see what that looked like. There's also some, I guess, there's also some input filtering capacitors, like these capacitors here that actually filter the frequencies coming in before it gets to the amplifier. These are filtering it out before it gets to the speaker, for instance. So, all right, this is the one that was worse off. I did test this 2N3055, and it tested fine. It was this one here, but since I had it out, I went ahead and replaced it because I have a whole bunch of these. I haven't tested capacitors. Cleaned it up, obviously. I put in the test points right there, which were kind of a pain in the butt to get in there. And then this is what the underside looks like of that damaged area. So it probably was wired up correctly. This is going to your 5 volts. This is not hooked up to anything. Right there. Kind of. But I think I just redid it because I wanted to make sure. Actually, it had to have been screwed up because the resistors were crispy as heck. So anyway, let's fire this up. I got my little test thing going on here. Kind of zoom out. See here, J6. And we are going to put my little sense mod jumpers on here, like that. And get my meter over here. Hook this on to my ground on capacitor C1. And I tested that tip 32. All right, here we go. Oh, I have my meter on backwards. See if this adjusts. And it does. That's with no load. So let me hook up a load to it. I have a 1 ohm resistor right here. That's going to be 5 amps on the 5 volt line. I just have to hook it up. Okay, with my load. Maybe I don't have this well enough. Alright, here we go again. Why am I not getting any voltage? Interesting. Is it not doing it with the load? Yeah, that's weird. It's not regulating with a load, so that could be the L, because I know it can't be this. Let me make sure all my connections are wired up. Okay, right. A little further inspection. and I see CR4. It was like that. I went to desolder it, and it basically just fell in half. So that could be our problem, CR4 there. Let me replace that. I'm pretty sure I tested tip 32 good. This should be good. Could be the voltage regulator not turning it on the circuit, I guess, but it sounds like it went into this. CR4 is probably the problem. Alright, I replaced CR4. Let's see what we get. Hopefully nothing smokes. Alright, still have a problem. That's weird. Yeah, it's not doing anything with a load. Maybe it is the voltage regulator at LM39, what is it, 305? That sucks. Well, I found my problem. I was pulling my hair out trying to look at this thing, and hopefully you can see this. Let me zoom in. I'm missing R24. No, R5. R5. This is R24, I think. This is R5 right here. And I'm missing that. I think it's a 2.7 ohm. Actually, let me check. I pulled one off right there. Zoom back out. Should be a 1 watt resistor, 2.7 ohms. Yep. And this one was missing it. So obviously, if you look at the schematic, here's your emitter of your tip 32 base collector, and you're getting the voltage off of the probably the base, I guess, of the Q33055, and basically it can't get to the tip 32 or something. I don't know. Regardless, these need to be tied together. Those need to be tied together, so it doesn't work out if it's not there. Here we go. Let's see. There we go. With the load, it's now working. And it is adjustable. And because it's adjustable, I probably should have known that that LM was fine. I had swapped it out with a different one, but I guarantee you this thing's fine. I think even if it's not, the load has to do with the tip 32 probably and the 3055, not maybe as much with the voltage regulator, but maybe, I don't know. I don't understand it well enough. Alright, so I fixed those other ARs, and I've been experimenting with my Rigol, I think that's how you say it, to try to figure out how I can measure the frequency response of these high pass passive filters here that are in line with the speaker. So on the plus side is basically where output from the amplifier comes to the plus side of the capacitor, and then it gets filtered to the negative, and the negative is tied to the speaker positive input. And let's see if there's anything else. I think that's it. And so I have both a lead on channel 1, my yellow lead right here is channel 1, and my second lead, which is channel 2, is on the negative going to the speaker. Now but if I don't hook up the speaker, there's no load on the circuit from the speaker. So to make it, I think, a complete circuit, you have to actually put the load on it. And so then, should I put the load here as well as there? I don't know. It's kind of weird. I haven't figured, you know, if that even makes a difference of what I'm trying to measure or not. But I'm going to put it on the normal side, as you can see there. Okay, let's power this thing on. And I actually have some Rastan music or other music here from YouTube. So we got that playing. Turn it on. So we got a little bit of sound. And I can do auto here. And you guys can hear it, I think. It's not that loud. Let me change my seconds per division to about... Oh, I'm doing the wrong thing. Duh. Oh, that's weird. That actually looks quite a bit different, doesn't it? The two signals. Oh, why did it put 2 on? There we go. They both should be 500 millivolts, unless I change something. Alright, let me come back and make sure that these are both set for the same, what is it, the vertical volts per division? Yeah, volts per division. Right now they're on different volts per division. I haven't messed with this thing long enough. I thought the auto would automatically set that right there, but I guess not. I have to hit channel 2, and then I can adjust... Oh, channel 2. Then I can adjust my volts per division like that, as you can see. So we're going to do 500 millivolts right there. And then we're going to adjust our seconds per division here a little bit. Let's hit auto. Oh, look, that's interesting. It did change it. It changed it back to 50 millivolts. What's up with that? There we go. I was having... Oh my gosh. I'm learning how to use this thing. Alright. Nope. Now let me hit auto. Is it only applied auto to the actual line that it's on? That's just bizarre. Yeah, that's what I'm used to seeing, is like more like this, like around 50. Oh, maybe I have to press it in to actually set it. Nope. So it changed it again. Alright, I finally figured it out. I had to screw with this quite a bit, so anyway, me messing with this is kind of helping me learn some of the functions of the Rigol DS1054, whatever. It's got more crap to it than I ever will probably figure out. Anyway, I have channel 1 and channel 2. Channel 1 is pre-capacitor, channel 2 is post-capacitor. And since I started this video, I actually posted a thread on Clav where more expert people, more knowledgeable people could weigh in and kind of tell me about what are these capacitors actually doing. So Mark from Hudson Arcade, Mark Spaeth, mentioned that yes, these are high-pass filters, but their primary purpose is to block DC voltage coming from going to the speaker. And then I did some research on that, and you know, it's unlikely that enough DC amps or current or voltage would go through. Current, I think, is the bigger issue to the speaker to cause problems, honestly. But in some audio stuff, they talk about, like, if you do send DC current, if you didn't have these DC blocking capacitors and you sent DC current to the speaker, then the speaker coil could get heated up and waste energy, as well as probably ruin the coil as well. So anyway, let me disconnect the speaker here real quick. So what did I want to cover? Okay, first off, I have my coupling set to AC instead of DC, so I might end up trying to measure the DC voltage as well. But you can actually press this measure button here, and then that'll bring up the measure menu on the right side, and then it says measure all, and we can just say yes, on, and then it gives us all of this stuff like max voltage on channel 1, max voltage on channel 2, minimum voltage, voltage peak to peak, I don't know, base amps, I don't know what, amplitude, that's probably amplitude. I don't know what this other stuff is because it's got this damn thing in the way there. Maybe if I turn that off. Can I turn that off? Dang, I can't get rid of that. Anyway. Channel 2. There, it's giving me a frequency measurement on channel 2. So this source, I haven't figured out what the source actually changes to, but the counter that you see right here is showing channel 2. Can I turn that off? Oh, I can. Cool. Right there. Boop. Now it's gone. All right. So area P, whatever that is, frequency, blah, 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 blah. Down here, you, instead of having to measure and measuring all of those and it taking up most of your visible area, you can hit the measure. Oh, I'm already on there. Turn that off. Okay. And then we can actually hit the menu on the left-hand side here, and it'll give us a chance to add some measurements to the bottom side here. And I can measure on a vertical, voltage max, voltage minimum, voltage peak to peak, voltage top, voltage base, amplitude. But what I'm more interested in, because we were thinking about frequency, is going to our horizontal menu, and then I hit frequency, right, and it's already on there. And you can hit like channel 1 period, and you see it adds the period over here. And if I hit channel 2 period, it would change that to, it can only display 3, so it takes the other 2 off. And then how do I get rid of that? There's a way for me to get rid of this, I think, somehow. Maybe do I hit measure again? Measure, tab down. Select item 2 maybe. We can get rid of all of them, I guess. Oh, I guess I can't get rid of all of them. Alright, that's one way. You can hit clear, and that will reset it. So I want to hit frequency, current one, frequency. Oh, shoot. I guess that's not what I wanted to do. Measure. Select item. I want 1, 2, 3. Okay, you can only have 3 items displayed. So we want our 2 frequencies. There we go. So this is basically giving me a minimum frequency and a maximum frequency seen on my channel 1 and channel 2. And if I kind of adjust this a little bit, my what is that, seconds per division, that's like kind of have to adjust it a little bit so it can actually measure the frequency in that period, I guess. And what is my seconds per division? 10 milliseconds right now. So in 10 milliseconds, this is telling me what my max and minimum frequencies are, and you can see they're pretty much identical. So I don't think that's really telling me much. I could go down, really try to get a better, more granular, I guess. 5 milliseconds. And they're like, it's matching up almost identical. It's like almost like the capacitors having little to no impact on the frequency response or blocking lower frequencies. 3300 microfarads. Did I show that? Let me bring that up at the calculator here. You can see this okay. So this is a high pass filter calculator, and if you say the speaker is 8 ohms, which is what my speaker is, and the capacitor is 3300, and I do calculate. Oh, that's farads. I need microfarads right there. Calculate. Alright, so my frequency cutoff would be about 6 hertz. So it makes sense. I shouldn't be seeing anything below 6 hertz in theory, based off of this RC high pass filter calculator. Now, one of the things Mark said in the thread is that the resistance of the speaker doesn't really make that much of a difference. Like, this probably doesn't apply to this particular circuit. But anyway, that's what I'm going off of. It was mentioning inductance versus resistance and stuff. But regardless, it makes sense that I'm not seeing anything below 6 hertz. But even if I did, I doubt the audio source I'm using is actually creating that signal. So I would have to use my... Actually, I guess, do I really want to get crazy? Can I actually use a frequency range here? Yeah, I could use a 1 hertz or a 10 hertz frequency generator and generate that through the cap maybe with my Tektronix CFG 250. See how I end up going down a rabbit hole, which has nothing to do with arcades, and I'm just screwing around. Anyway, let me see if I want to talk about anything else. The bottom line is this is blocking DC voltage or amps going through, preventing it from getting to the speaker. Has nothing probably to do with the sound per se, except for blocking DC voltage. And I might actually put this on my Tektronix scope here real quick, just to show you what it looks like when I use AC and DC coupling, because the digital scope is a little bit better at using one versus the other. I don't know exactly why, and picking up a signal and stuff, because it does a lot of stuff automatically, whereas when you get into like manually setting trigger levels and couplings and stuff, you know, the older scopes are less forgiving than these automatic like digital scopes and stuff like that. But I thought that was cool anyway. Like, you can choose different measurements. You can hit your fall time, choose your channel, press what you want to measure. It basically puts it right on here. It's super simple and easy once you get the hang of it. There's so many features to this damn thing. It's super cool. And then you can also always just hit measure all, which I found really super cool as well when you're comparing two different signals especially. And then you can do math, which again, way over my head, but you can do like, you know, calculations and stuff. You can subtract A from B and do all types of weird, you know, stuff with this crazy scope here that I don't understand. So, all right, just to explain why I wasn't able to get my volts per division the same and have both signals on the same, what is it, graticule or whatever we're looking at the screen, is because I was using, when I hit auto, it was using DC coupling. And so watch when I hit auto here. We'll just go back to where I was before. So you can see if I hit channel 1, it's using DC coupling. If I hit channel 2, it's using DC coupling, right? And my volts per division on 2 is 100 millivolts, and it's 500 millivolts on channel 1. Kind of interesting, right? Now if I hit the channel 1 and I change my volts per division to 100, whoops, wrong thing, 100, you see it says something like out of range. But if I choose AC coupling, I should be able to, oh, whoops, channel 1, AC coupling. And then if I adjust this, what do I want? 100 millivolts. Where am I at? There we are. There's my signal. Oh, it's actually almost like right on top of the other one. As you can see there, but yeah, I can get in there. Why is that? Now, channel 1 is pre-capacitor. This is coming from the amplifier, and so this is where I need to study the DC voltage and stuff. There should be no DC on there to actually do the trigger anyway. So, but hey, that's kind of weird. Why I don't know. I keep adjusting the wrong damn thing. Right there. But anyway, that's how channel 2. I can do DC coupling, and it is able to pick up the signal and trigger. That's what I was getting at, as far as like this thing is a little bit, because it's a digital oscilloscope, it's a little more forgiving, I guess, because I probably shouldn't be able to trigger based off of DC coupling on a signal coming post this capacitor. There really shouldn't be any DC signal at all. Or maybe the DC signal is closer to 0 because it's filtering that out post capacitor, and that's why I can trigger on it, is because it's 0, whereas there is a little bit of DC voltage maybe pre-capacitor. I don't know, that's kind of interesting. I have to think about that a little bit. Alright, let me see. This video, so I hooked up my other scope there, my Tektronix, and I have my vertical selected to both channels. I'm doing chop mode. Seconds per division is, I think, 2 milliseconds, or 0.2. 100 millivolt. Oh, 500 microsecond. Maybe that's closer to what we're seeing down below, depending on what you're looking at there. Yeah, 500. Okay. So, and then I have my volts per division on 0.1, so that's matching. And if I go to DC voltage, you can see I have nothing on channel 1. Channel 2 just went away too. Go back to 8, there's nothing triggering. And I think I'm triggering on A, right? Alternating. Yeah, see, I need to work with my oscilloscope knowledge. But you get the idea. Is if on channel 1, if I go to DC, there's nothing there. I can't trigger on anything. And let me go channel 1, and let me do a measurement of DC. I forgot how to do my DC voltage. This is from the side right here. I had to select that. So now I'm on DC volts. I have 5 volts. Let me come to right there. See what voltage we get. 6.52 volts, DC volts. Pre-capacitor, and 0.13 post-capacitor, as you can see there. 0.13 DC volts post-capacitor. No, can I do AC voltage? .01. Basically the same. Go to DC, 0.12 post capacitor, and 6.5 pre-capacitor, as you can see there. Now I probably could have done that with this as well. I haven't figured it out. Anyway, that's enough of me screwing around. Fix the AR. I'm just kind of, learning Jack Lick's journey. That's all it is. Me screwing around. All right. Regardless, you don't normally need to go through all that. I just figured I would show you me experimenting. Blah blah blah. Anyway, so I was able to figure out how to get more measurements across the screen. You can get up to 5 if you use the smaller font size. So I think that might be in display or utility. No, display. Let's see. Maybe it's under measure. Yeah, font size, normal. If we go to large, there you go. Actually, that makes it a little bit easier. But voltage max, see, it's showing you in millivolts, but if I go to turn off channel 2 and I use DC coupling, no, I'm only doing channel 1, so in channel 1 I'm going to go to DC, and we do have some DC voltage. I need, because 100 millivolts is too granular to actually display the amount of voltages on there, we have to change that to, let's just call it 1 volt, and then we should be able to get this on the screen, I think. There we go. Yeah, you can see the signal on the screen, but I'm looking at the coupling on the DC voltage, and I can't look at why. Oh, there we go. 6.6 volts. I just needed to change the time frame here. Going to about, I'm at 2 microseconds. Nanoseconds? Alright, let's go to like a second. There we go, 500 microseconds. There we go. Yeah, it's 6 point something volts. And if I do the same thing on channel 2, DC coupling, channel 2, we need to change our voltage per division to 1 volt. And then I need to do voltage max on channel 2. And yeah, we're down in the millivolt range, right? Come on now, channel 1, voltage max. It's not letting me overwrite one. Why is that? Channel 1. Channel 1. Existing item. Right there, voltage max. Why isn't it giving me a reading? I don't know why it's not giving me a calculation. Let's clear it. Oh, it says period. I don't want period. I want voltage max. Gotta figure out how to display all this damn shit. There we go. That's duh. Now I need to go channel 2, voltage max. It says it's a current item. This is kind of annoying to figure this out. Measure, select item. Is it item 2? No. Item 3? Item 5? There we go. That's odd. Yeah, screw the large font size. I want to be able to see everything I have selected. So yeah, we're looking at same thing that we just measured over here. We're looking over here and we're able to see that we got 6.6 volts, around 6.7 coming into the capacitor, and then only 200 millivolts. So the capacitor is definitely doing its job. And now let's move it to the other capacitor right here. I just have to switch it around because they are opposite directions. And you can see this capacitor is not, seems like it's not blocking as well, because I have almost 800 millivolts coming out the other side versus relatively the same DC voltage coming in. I have about 6.5 volts coming in and around 720, whereas before I was down into the 200 millivolt range. So is this capacitor not as good as this one based off of that characteristic? That's interesting. Down the rabbit hole. So I'm going to further the experiment here, messing around. I'm actually going to short this cap. One of the things, I think it's called dielectric loss or something like that, is as a cap ages, yes, you can get worse capacitance. This is based off of me reading, or higher ESR, but you can also get like weird behaviors like the cap doesn't discharge. So I'm just going to tap that. Okay, there's no charge left in that, so that's good. But I just want to discharge. Oops, see, there was a little spark in that thing, right? What does that mean? Maybe nothing. You know what I mean? This one actually did didn't have a charge on it, for example, but this one did, if you saw that spark right there. So I'm going to desolder these two caps. We're going to measure them the best we can, and then I'm going to replace them with a couple from Peter, some newer caps, and we will remeasure the DC voltage blocking going through the caps with the new caps. Alright, so I don't really love this ESR meter, but at least as far as comparing things, it should be somewhat decent. Zero out my leads. Alright. So our A capacitor, and you definitely want to discharge or short the cap before you do this. Our A capacitor is 0.249 or 0.25. ESR, our B capacitor, which looked like it was leaking more DC voltage through, or not blocking it as well, 0.26. So very nominal difference, I would say, as far as that goes. And let's see what two of Peter caps look like ESR wise. Definitely better, 0.1. Yeah, so definitely better from a comparison standpoint. Now, I think my capacitance meter, I don't think it goes up to 3,300, I don't think. Let's see. Point 3.46. What is that? Millifarads? So which would be 3,400 microfarads or something. Alright, 3.48. This is cap B. I should really do it without my fingers on it too, but... .6, so it's actually, you know, drifting higher. .6 for B. Yeah, 3.6 for that one as well. So really no difference in measuring either of these, but why was B allowing more DC voltage through, even though it was measured in the millivolts? So I am going to recap this power supply and we will remeasure. But as far as the capacitors, like measuring capacitance, measuring ESR, these did not look significantly different from each other. And these have a little bit better ESR, a little bit closer in spec to the microfarad or capacitance, but not something that you would think, oh my god, I gotta yank these out of there, because there might not be any difference at all. But we'll find out. Maybe there's some other internal testing that we're not doing, like, you know, dielectric loss, something, leakage. So alright, I only have a couple minutes left, but new caps in, and the audio signal influences this a little bit. So if I turn it all the way down, pre-cap we have 6.6 volts coming in, post-cap we got 40 millivolts, and that's on that cap right there. And I did not do the same measurement, so the audio signal definitely matters. Now I gotta switch it around. Hopefully I have some time on this recording with no signal. We have, let's see here, did I switch it around correctly? Yes. Clear this. That's odd. What's going on there? Let's try this one more time. So I have my signal playing and Rastan voltage, and this is channel 1, this is channel 2, pre-capacitor, post-capacitor. Yellow is 6 volts, and then it says current. Let's clear that. It says like 2 volts. What? That sounds crazy. Let's turn the volume down. Why am I getting such weird readings? So strange. That doesn't make any sense at all. I'm on DC coupling, right, for both channels. Yep. Alright, let's switch them around. So my channel 2 comes up here. Now I'm wondering if having the speaker actually hooked up is part of the voltage measurement difference. Yeah, see, now it says 6.6 volts going in to capacitor number 2 and around 80 millivolts depending on the signal, obviously. And this is DC coming out. And you go all the way down to 0 signal, you got 40 millivolts, 6.5 and 40 millivolts with the speaker hooked up. Right there. Alright, now let's switch it around. And now let's move our speaker. Yeah, the speaker is kind of the change there, adding that resistance or inductance. no signal, 6.6 and 40 millivolts. So pre-capacitor, post-capacitor with no signal. So unfortunately, I did not do a good enough comparison or thorough enough measurement with the old capacitors on there, but whatever. I don't know if I can draw any conclusions. I would say that the caps were probably fine, but I just replaced them anyway. And I would say you probably don't need to, as Andrew B says, or maybe next time I do a better comparison. That's an 8 ohm speaker, by the way. Let's do AC. Come on now. There we go. And let's change our volts per division. No, I got it on AC coupling. But anyway, that's it, guys. That's it for the video. I'm just screwing around anyway. Capacitors, whatever. That's it. Cheers.